let's talk about function composition. So function composition puts two functions together by plugging the result of one function into the other as the input. So we have two example functions here on the screen. We have f of x is 4x minus 3 and g of x is negative 2x plus 7. So we've got three little sample questions that we're going to do. The first one we're going to do is we're going to find f of g of 5. So you always want to start on the inside first. So we're always going to do this first. So the first thing we're going to do is find g of 5. So we're going to find g of 5. So that means everywhere I see the x in the g equation, so right here, I'm going to plug in 5 instead. So my g equation tells me to do negative 2 times my input plus 7. And I'm going to replace my input value with 5. So negative 2 plus 5 is going to be negative 10, plus 7 is going to give me negative 3. So then what I'm going to do second is I'm going to put that into my outside function. So the second thing I'm going to do is find f of negative 3, so my answer from the first part of the problem. So my f equation, right, we'll use this color, I guess, right, everywhere you see the x in the f equation, we're going to plug in our input value. So for f, we're doing 4 times our input value and then minus 3, and we are plugging in negative 3. So 4 times negative 3 gives me negative 12, and then I'm going to subtract 3, so that's going to give me negative 15. So my final answer up here is going to be negative 15. Let's do another example. So now we're going to switch the order. So now we're doing the f equation first on the inside. So the first thing I'm going to do is find f of 4. So again, our f equation tells us to do 4 times whatever the x value is our input and then subtract 3. And we're going to put 4 inside of those parentheses. So 4 times 4 is 16, and then minus 3 gives me 13. And then I'm going to take that and plug it into my outside function next. So g of, now I'm going to be plugging in 13. And g tells me, if I look at my g equation, to do negative 2 times my x-coordinate plus 7. So now my x-coordinate is 13. So negative 2 times 13 is negative 26. And then I'm going to add 7, and that's going to give me negative 19. So my final answer to this question is negative 19. So with function composition, you can do it with just the equation. You don't actually need to have an original input value, an x-coordinate or a number. So in number 3, what we're going to do is we're going to find f of g of x. So we're going to find a totally new equation by combining these two. So we're going to start with the inside function again. So my inside function is g of x. And all I'm going to do here is write down what my g of x equation is. So it's negative 2x plus 7. And I'm going to plug that into my outside function. I'm just going to go over here to save some space, which is f. So my f equation, everywhere I see the x, I'm just going to put an open set of parentheses because that's where I'm plugging in. So it's going to become 4, and then instead of x, I'm going to have my parentheses set there, and then minus 3. And what we're going to do here, instead of plugging in a number, we're going to plug in this whole equation for g of x, because that's what g of x is equal to. So we're finding f of negative 2x plus 7. And I'm just going to put that inside my parentheses. So now because I have a 4 outside of parentheses, I know I'm going to distribute my 4 through there. So 4 times negative 2x gives me negative 8x, and then 4 times 7 is 28. And then I'm just going to bring down my minus 3 that I haven't touched at the end yet. And then to finish this, all we're going to do is combine our like terms. So negative 8x, and then 28 minus 3 is going to give me 25. So my final answer here is going to be negative 8x plus 25.